In this short video, you will understand what is the prime factorization of a number. Prime factorization is like breaking a number down to its core elements. Let's dive into this topic with a few examples. Prime factorization means expressing a number as a product of prime numbers. Remember, prime numbers are the numbers that only have two factors, 1 and themselves, like 2, 3, 5 and 7. To perform the prime factorization, we need to follow some steps. We need to start with the smallest prime number, that is 2. Check if the number is divisible by 2. If yes, then divide it and repeat this process until it is no longer divisible. Then move to the next smallest prime number, 3, 5, 7, so on. Repeat the process until the number is reduced to 1. Multiply all the prime numbers you use to divide to get the prime factorization. Let's see an example with the number 24. Divide 24 by 4, which is the smallest prime number, to get 12. Again, repeat the process to get 6 and 3. Finally, 3 is a prime number, and or as we divide this 3 by 3, which is another prime number, we get 1, so we stop. So the prime factorization of 24 is 2 raised to the power 3 times 3, or 2 to the power 3 multiplied by 3. Now let's try it in a 45. It is not divisible by 2, so we start with 3, giving us 15. Again, we divide this number 15 by 3, which will give us 5. So 5 is a prime number, so we stop here. So prime factorization of 45 is 3 raised to the power 2 times 5. And finally, let's factorize 100. Start with the number 2, which will give us 50. Again, we divide this number 50 by 2 to get to 25. Now we switch to 5, giving us 5. Then we divide by 5 again, which finally gives us 1. So 100 equals to 2 raised to the power 2 times 5 raised to the power 2, or 2 squared multiplied by 5 squared. Let's see some practical examples with the prime factorization. Prime factorization is key in mathematics and real life. Greatest common divisor, or GCD. To find the largest number that divides the two numbers, find the GCD of 24 and 36. Prime factorization of 24 is 2 raised to the power 3 multiplied by 3, and prime factorization of 36 is 2 raised to the power multiplied by 3 raised to the power 2. So common prime factors are 2 raised to the power 2 multiplied by 3, which is 12. So GCD of 24 and 36 is 12. Least common multiple. To find the least common multiple of two numbers, we can use this prime factorization. Now let's find the least common multiple of 12 and 15. So prime factorization of 12 is 2 raised to the power 2 times 3, and prime factorization of 15 is 3 times 5. So take the highest power of each prime, that is 2 times 2 times 3 times 5, which is 60. So LCM of 12 and 15 is 60. Real life example: secure communication in cryptography. Prime factorization is the foundation of encryption system like RSA, which secures the online transaction. For example, a public key might be based on the product of two large prime numbers, say 61 and 53. 61 multiplied by 53 will give us 3233. Breaking this into prime factors to decrypt the data without knowing the prime is computationally hard, ensuring security. Engineers use the prime factorization to design circuits that operate efficiently and avoid frequency conflicts. For example, suppose a circuit uses two oscillating frequency components with the frequencies 45 Hz and 60 Hz. To avoid prime interference, engineers calculate the LCM of 45 and 60. So prime factorization of 45 is 3 raised to the power 2 times 5, and prime factorization of 60 is 2 raised to the power 2 times 3 times 5. So LCM of two numbers is 180. So the circuit should operate at 180 Hz to maintain the stability and prevent conflicts.